In this video, we're going to take a closer look at box whisker plots. Here we have the familiar box with the first quartile, the 25th percentile, 25% of the data below it, 75% above it. We have the median, also called the second quartile, and so you have 50% of the data below it and 50% of the data above it. Third quartile, 75% of the data below it, and that's the third quartile. So what about these little dotted lines? And these are called whiskers. Whiskers typically go from the right-hand hinge of the box to the largest or maximum value, but I'll have to clarify that. In the presence of outliers, it goes to the largest number that's not an outlier. So this is not necessarily the maximum in the presence of outliers. We have no outliers on the left, so this is in fact the whisker going to the minimum value. So how do you calculate an outlier? By calculating something called an upper fence. It's over here somewhere. You don't see it in the box whisker plot. It's an imaginary line that you calculate, and it doesn't appear in the box plot. It says if you're above this number, you're an outlier. That's called an upper fence, and the way you calculate it is you take the third quartile and you add 1.5 IQRs. That's for an upper fence. A fence that is to the right. Now, even though there aren't any lower outliers, in a typical situation where you don't know if there are any low outliers, you have to calculate a lower fence. Similarly, instead of Q3, it's Q1 because it's on the low side. Q1, and we're going to move to the left, so we're going to subtract 1.5 in IQRs. So it's an imaginary little fence here. It says, if you're below this number, you're an outlier. So what are the advantages of fences? They highlight what the outliers are. All the values that fall outside of the fences are outliers. Now we're going to go to a quite different topic. Another feature that is important of graphs, graphical displays of data, is something called skewness. Symmetry is the easiest to explain. If you're symmetrical and you're a histogram, when you draw an invisible line through the mode, the right-hand side will be exactly the same in shape and size as the left-hand side. That's what it means to be symmetrical. These two sides are mirror images of one another. That is not true in these graphs. In this graph, if you were to draw a line through the mode, there'd be a lot more area, so to speak, to the right. This is called right skewness, and since it's moving in the positive direction, it's also called positive skew. In this case, since there are more large values, the mean is going to be bigger than the middle point, the halfway point, the point that separates 50% of the data on the left and 50% on the right. So this is kind of important. If it's skewed to the right, these two statistics are not going to be the same. In fact, the mean will be bigger than the median for positive skew. Left skew is just the opposite. Draw an imaginary line through the middle. The data is pointed, and most of the data is to the left of that line. So it's called left skew, or it's moving off to the negative numbers. So it's also called negative skew, in which case all of these small numbers are going to, when you average all these numbers up, all of these small numbers are going to make for a small mean, and the median is the 50% mark. It'll be somewhere over here. So this is important. When it's left or negative skewed, the mean will be less than the median. Can you tell skewness? Oh, my editing here was really off. These things here, these little boxes should be moved down. Okay, we'll make that look pretty. Move them down. Okay, now it looks pretty. Okay, so if it's symmetrical and you have a box plot, the center hinge will be right in the middle. If it's positive skewed in a box plot, the center hinge will be not to the left. Don't think of it that way. Think of it this way. It's where the larger area is, okay? Where the larger area is, where most of the data is. It's skewed to the right, positive skewed. It's kind of the fat end of the box plot. Negative skew, of course, is the opposite. Negative skew is the center hinge is not in the middle of the box. The fat end is towards the negative side, and this is called skewed to the left. So you can tell skewness from a box plot, and you can tell it from a histogram. So you'll see this language floating around. What is the 5-number summary? It is the minimum, the first quartile, the second quartile or the median, the third quartile, and the max. It's 5 numbers that describe the data. Notice the standard deviation isn't in there. The mean isn't in there. It's all about the quartiles and the maximum and the minimum. That's the 5-number summary. So a little parting wisdom here. If you have a skewed distribution, whether it's left or right, the mean is a little bit misleading, so you're going to prefer the median, and you're going to prefer the IQR. Okay, because in skewed distributions, things aren't as they should be, so the mean and the standard deviation that are a little bit misleading. They only occur if it's symmetrical. You're going to say, okay, things are just as they should be. Let's go with the mean and the standard deviation. If things aren't quite what they should be, then the mean and standard deviation might be misleading, and you'd prefer the median and the IQR. So symmetry, mean and standard deviation, because nothing is misleading. Skewed distribution, prefer the median and the IQR. So we have certainly covered a lot. We've talked about outliers and fences and skewness, 5-number summary, and I'm going to leave you with that. I hope this has been informative and useful and that you enjoyed it. And I will see you at the next video.